Okay, this is the answer key to exercise set 2.1. I'm going to give this to you on Monday to help you. Now, the important thing when you're doing the homework, the idea is not to just follow this answer key. Like, I want you to follow part of it. And it's like, as soon as you understand it, do the problem. But if you don't understand, like, watch as much as you need to, but don't just copy. Really pause the video and push yourself as needed. Okay. All right. First one, average rate of change on interval -1, 5. So visually, what this looks like is we have this graph x squared minus 4x, which looks something like this, right? And I'm trying to find the average rate of change from -1, let's guess that's right here, to 5. Let's guess that's right here. So what I'm looking for is the slope of this line. I'm guessing at these points right now. So I know that this is -1 something, and this is 5 something, right? If you imagine that, we got these coordinates. So we're going to use that equation we used in class today, y2 minus y1 over x2 minus x1. Okay, so I need to identify these values. So my x's I have, x1 is -1, x2 is 5, but I need my y's. To find my y's, I need to find the outputs at these values. So I'm going to find f of -1, my y value at -1, and I'm going to find f of 5, my y value at 5. Okay, so that's -1 squared minus 4 times -1, that is 5, right? 1 plus 4 is 5 is what that simplifies to. Then I have 5 squared minus 4 times 5, that is also 5, because 25 minus 20 is 5. So when I plug this in, this is my y1 right here, and this is my y2 right here. When I plug it in, I'll get 5 minus 5 over, let me plug these in over here so it's clear, over 5 minus -1. So that simplifies it over to 0 over 6, which is 0. So what that means is, if I go back over here, that these 2 points are actually parallel, right? They are at the same y value. So the slope, if you think about this, slope equals 0. And also just a reminder, this is the secant line. Secant. Okay? Versus the next one, we're finding the instantaneous rate of change at x equals 3. So visually what we're looking at, again, if you draw this out, something like this, I go to 3 and I'm drawing a line straight through this. One point, this is the tangent. Okay, tangent line. All right. Find the instantaneous rate of change at x equals 3 using the limit definition of a derivative. So what you would say is, this is the equation from class, limit, what we're looking for is limit as h approaches 0 of f of x plus h minus f of x over h. Now, I'm given an x value, x equals 3. That means I can plug that in. So really what I'm looking for is, remember, substitute every time wherever you see an x, you're plugging in a 3. So really what I want is f of 3 plus h minus f of 3 over h. That's what I want. So this is where we need to kind of slow down. So I need h stays as it is. You are not going to change anything with h. You're not going to bother with this. But I need to find f of 3 plus h and f of 3. F of 3. I know what f of x is. Remember, f of x is up here, importantly. X squared minus 4x. So f of 3, I'm gonna sort of break it down part over here. F of 3 equals 3 squared minus 4 times 3. If you look up here, I'm squaring. 3 squared minus 4 times 3. That is 9 minus 12. That is -3. Okay? -3. All right, makes sense? F of 3, when I plug in 3 into the function, I get -3. That's f of 3. So I know what I'm going to put there. Then f of 3 plus h. This is more complicated. This is hard to get your head wrapped around of. So if we think about f of 3, all we did for f of 3 is we plugged in 3 for x, right? That's what you do. So if I'm doing f of 3 plus h, you're doing the same thing, except instead of putting in a 3, you got to put in a whole 3 plus h. So it equals 3 plus h squared minus 4 times 3 plus h. Okay? Again, all I'm doing is substituting that 3 plus h in for x. Instead of 3 squared, 3 plus h squared. Instead of 4 times 3, it's 4 times 3 plus h. Now that I've got my two values here, I can substitute them in. So f of 3 plus h, I'm going to write it over here. 3 plus h squared minus 4 times 3 plus h minus negative 3. Okay, so this right here, 3 plus h squared minus 4 times 3 plus h, came from here. F of 3 is negative 3, so that goes there. This becomes this becomes this, all over h. Our next step is to simplify this. We got to kind of expand, multiply, and then combine like terms. So starting with this 3 plus h squared, I'm going to show you that to the side. Just to review, 3 plus h squared is just 3 plus h times 3 plus h. Multiply, I get 9, 3h, 3h, h squared. Altogether, h squared plus 6h plus 9. So this 3 plus h squared is really h squared plus 6h plus 9. So I'm going to write that out here. H squared plus 6h plus 9 minus 4 times 3 is 12 minus 4 times h is 4h, so minus 4h, and then minus and negative 3 is a plus 3. Let me just divide that out so it's not part of it. All over h. Still over h. Okay, so again, pause, slow down if you didn't understand that. 3 plus h squared is h squared plus 6x plus 9. Negative 4 times 3 is negative 12. Negative 4 times h is negative 4h. And then minus the negative 3 is plus 3. Now I want to simplify this. So notice 9 plus 3 is 12. Minus 12, they all cancel. It all adds up to 12. So these three cancel. 3 plus 9 is 12. 12 minus 12 is 0. They all cancel out because 12 minus 12 is 0. Then I have 6h minus 4h. 6 minus 4 is 2. So what I now have is h squared minus 2h over h. Divide both sides by h, and I get h plus 2. My bad, this is 6 minus 4 is plus 2 here. So h plus 2 is what I end up with. And remember, I'll rewrite it here. The limit as h approaches 0 of h plus 2, all I'm going to do is plug in a 0 in for h, and I'll get 2. So the slope, the instantaneous rate of change of this line right here is essentially 2 over 1. It goes up 2 over 1. Okay? So again, I think the most challenging part of this is the separation here. So finding f of 3 and f of 3 plus h, and then plugging that in. And then you've got the expansion. So you just want to take your time, break things down one at a time. 3 plus h squared, and rewrite things. Use it on the sheet of paper, take up a lot of space. The next one is very similar, except the only difference is I'm not given any x value. So this notation here is the derivative. This f prime of x, that means derivative, the instantaneous rate of change, equals IROC, instantaneous rate of change. These are all the same thing. So you're using the same equation. Limit h goes to 0 of f of x plus h minus f of x over h. Now this time I don't have an x value. So here I had the 3, so I could put the 3 in. I don't have a 3, so you're going to not put anything in. Okay, so f of x is, I'm going to write it off to the side here. F of x equals 4x squared minus 5. So I know what's going to go here, right? This is just going to go here. And then f of x plus h, remember that just means take the x plus h and plug in for x. So you have is 4 times x plus h squared minus 5. Okay, let's plug it in. So it's going to be 4 x plus h squared minus 5 minus 4x squared minus 5. And I'm putting parentheses around it because it's a whole thing, all over h. Okay, now we need to simplify the numerator. So x plus h squared, I'm going to start with this, x plus h squared. X plus h, multiply them out, I get x squared, xh, h squared. Altogether, x squared plus 2xh plus h squared. Okay. Now notice there's a 4 in front of that. I'm going to break this into several steps. So that's going to be 4 out front, and then I'm going to replace that x plus h squared with this, x squared plus 2xh plus h squared. The minus 5 stays. And then double into minus 4x squared right here. And then minus negative 5 is plus 5. All over h. Okay? So I can simplify this again more by multiplying out that 4. 4 times x squared is 4x squared plus 8 xh plus 4h squared minus 5 minus 4x squared plus 5. So some things are going to cancel here. Notice this negative 5 and the plus 5 are going to cancel, and the negative 4x squared and the 4x squared are going to cancel because they're just opposites of each other. So what I'm left with is 8xh and 4h squared. Okay, so let's rewrite again down below. I'm going to write it as 4h squared plus 8xh over h. Well, if I divide both by h, I can take the h out. So I now have 4h plus 8x, and then I'm there. So here's what I do. You're done at this point. You might be thinking, oh, what about that x? The x stays. I'm going to take the limit as h approaches 0 of 4h plus 8x. When I do this, direct substitution, plug the 0 in. What you have left is 8x. So what that means is, so the derivative of x, f prime of x, right, equals 8x. That means the slope at any given point of the line tangent to that point, the instantaneous rate of change at any point is 8 times the x value. I'm going to write it like that. Instantaneous rate of change at any x value is equal to 8x. Okay. Write but do not evaluate an expression that gives an instantaneous rate of change of g of x at x equals 2. So this is not, we don't need to evaluate anything. We're just writing it. So one more time, limit h approaches 0, f of x plus h minus f of x over h. I'm writing it, but I'm not evaluating it. And it says x equals 2. So I know that it's going to be f of 2 plus h minus f of 2 over h. So I'm just writing it. It's going to be limit h goes to 0 of negative 1 over 3 times 2 plus h minus negative 1 over 3 times 2 all over h. So all I did there was plug in the 2 plus h for x in the first one and the 2 in for x in the second. Okay. All right, last one. Okay, last question. Jasmine rolled the ball down steep ramp and got the distance function t 2.3 t squared, where t is measured in seconds and s of t is measured in feet. Sketch a graph. So just a graph is going to be, something like this. Right? You can go in Desmos and be more specific, but this is the gist of it. Time is only positive. We don't have negative time, so it's just going to be upward quadratic like that. Average rate of change, we went from zero, the interval essentially from 0 to 3. So this is like the first problem on the back. Go ahead and try it. You can do this. So you're going from here over to 3, right? So at 0, right, my y is 0. This point here is 0, 0. When I plug in 0, I get 0. And then this point at 3, when I plug in 3, I'll get 9 times 2.3, which is 9 times 2.3. Okay, again, 9 times 2.3 is 20.7. So the average rate of change is 20.7 minus 0 over 3 minus 0, which is 6.9. So the average rate of change is 6.9 feet per second. Okay. Then the instantaneous rate of change, this is another limit problem. So again, that formula, again, limit h goes to 0 of f of x plus h. I'm going to write it as x because the pluses and the t's just get so ugly. So even though it says t, I'm writing it as x. So I'm changing it to x. Minus f of x over h. So remember, I'm given that value, so then I can plug in the value. So I don't have to do it like that. So I'm going to do f of 3 plus h minus f of 3 over h. F of 3, we actually already found f of 3. Remember, it was 20.7. So I know that. F of 3 equals 20.7. And then f of 3 plus h equals, you're just going to plug in 3 plus h for t, 2.3, 3 plus h squared. Okay, so now I'm going to substitute these in. So it's going to be limit at h goes to 0 of 2.3, 3 plus h squared minus 20.7 over h. Okay, the 3 plus h squared, let's do it to the side here. 3 plus h, 3 plus h, 9, 3h, 3h, h squared. Okay, so we have h squared plus 6h plus 9. That's going to substitute there. So we have 2.3 h squared plus 6h plus 9 minus 20.7 over h. Continues. 2.3, this is going to be, I'm just multiplying out the 2.3. So we have 2.3 h squared plus 2.3 times 6 is 13.8 h. I'm going to pick this up right here. So because I'm running out of space. Okay, so I'm gonna rewrite it right here. So I'm gonna have when I multiply these out, 2.3 times this, I'm gonna have 2.3 h squared plus 13.8 h plus 20.7 minus 20.7 over h. These cancel because it's plus, positive, and negative. This is nothing right here. Okay, this is 20.7 minus 20.7. Those cancel, so I'm left with this over here, and I'll do it in steps so it's clear. This is the same as 2.3 h squared plus 13.8 h over h. I can take out an h of both of these and divide them by h, right? So I can take out an h of both of those at the top. So this equals 2.3 h plus 13.8. That's my simplified version. I'm going to take the limit of that. Limit as h goes to 0 of 2.3 h plus 13.8 equals, sub into 0, 13.8. So the instantaneous rate of change at 3 seconds would be 13.8 feet per second.